beginner series is back with a new challenge called Find the Remainder. Your task: write a function that accepts two arguments and returns the remainder after dividing the larger number by the smaller number. They note that division by zero should return NaN, which is short for not a number. And then they go on to say how you would do that. You're going to throw a new divide by zero exception. I don't think we've talked about exceptions yet in this series, so we'll address that too. They will provide us with an example section to make this clear. Note that if you take 17, right, the larger number, divided by 5, you get 3 with a remainder of 2. And then they've got another, so it returns 2, the remainder. Then they do a couple other examples. Feel free to look through these. Notice the smaller number in both of these last two cases is 0, so we get our sort of not a number thing going on. And then 13 and 72, this was to highlight that the arguments can come in any order. You can't assume that A is always going to be larger than B, so we're going to have to do some checking for that. And if you do that math problem, it should have a remainder of 7. So input arguments will both be integers. Yeah, we know that. This is a contract, right? We sort of talk about methods as contracts. There, people who invoke it are obligated to pass this information in, and then the people who are implementing the function are obligated to return whatever the return type is, an integer in this case. So remember, callers, that's their obligation. They provide this information, and whoever implements the method, writes the guts of it, you have to return an integer. And then of course, you're often going to be fulfilling both of these roles. You're the person calling the method and implementing it, but not always, but usually, if you work, by yourself or in a small team. So I think that's enough information to get started. This is a good exercise because it's returning a remainder. So if you remember a couple challenges ago, we learned a new operator for getting the remainder of a division problem. So this will be a good refresher to make sure that's still in your head, in your toolbox. So go ahead and pause this if you'd like to try. And now I will get started. So they kind of had this placeholder in here, throw new not implemented exception. And it's nice that they did that since we're just coming to exceptions. We get this new throw keyword. This new kind of looks like when we create new objects, right, of a class. We'll get more into instantiating classes, but we've talked a little bit about that. So you can think of it like making a new exception of a certain type and then throwing it. And so what's nice about exceptions is that you can think of it like an error in the program, but instead of the program just crashing, you actually get the opportunity now to handle the error. Maybe you can recover from it, maybe you can save some important data before you have to crash, or I'm sure you can think of how that might be useful instead of just crashing and burning out. So they mentioned this divide by zero exception. We're going to be using that for our purposes. This not implemented exception would be useful. Let's say you are really busy, you kind of stubbed out this remainder class in your work, and as a placeholder you just kind of throw this in, so when you go run your program, it'll throw a warning or an error at you, an exception, that you forgot to implement that. The alternative would be you just sort of say return 1, just as I don't have time to do this right now, I'm just going to say return 1 so the compiler doesn't yell at me and it lets me run my program. But then imagine you do a bunch of other work and you totally forget you've done that, and then you're wondering why you always get a remainder of 1 and it's just bizarre to you. So that's where the other exception could be kind of nice. So anyways, we now have an idea of what exceptions are. And as usual, great reference is the Microsoft Documents page if you want to go over here and look into the throw keyword, more about what exceptions are. And you can always ask me questions too if you want. So we will continue. Let's handle this first problem of which number's bigger, right? Because we don't know if A is larger or B is larger, but it matters for the order of division. With addition, you don't really care what order the operands are in, right? You get the same result. But with division, you most definitely do. So we'll do this with if statements, but we can do one with the ternary operator at the end, or maybe I'll leave that as an exercise. I'll create a local variable then in my method, and I'll just call them larger and smaller to hold the two values, and then I sort of identify them and I know which one's bigger. Note that what I did here is sort of a shorthand. This is a nice thing where if you have variables of the same type, integer in my case, you can just comma separate them and put them on the same line. But if you don't mind being on another line, you can do this as well. Okay. I'm going to go back to this one. Only use up one line and it's very understandable in my opinion. So we'll say simply if A is greater than B, right? We can say set larger to A's value and set smaller to B's value. And then otherwise, the other case is that B is either equal to A or it's less or it's greater than A. Then we'll want to say larger equals B, smaller equals A. And again, note that we don't run into any trouble here if A and B are equal. You can pause and think about that for a moment if necessary. Okay, so at this point, we know which number has to be the dividend, which one has to be the divisor. So let's handle this bit about 0, because we know we're going to be dividing by the smaller value. So let's check that. If smaller is equal to 0, that's when we have a problem, right? You can divide by anything except for 0. Then we want to use this new exception object, and they say, remember those start with the keyword throw. You're throwing it. I mean, you can think of it that way because it can sort of bubble up to the function that called this remainder function, and then that function can either handle it or throw it somewhere else, you know. So that's probably why it's referred to that way. Throw new divide by 0 exception. Okay. And then, you know, you sort of add these protections to your program. Ideally, you never get there. People should never divide by 0, right? We should know that, but in the real world, it happens. You know, maybe it's not, the smaller number isn't being entered by somebody, but it's sort of the result of a calculation that you never thought could come out to be 0, but there was a weird case where it did. So it's not even always that people are being malicious. These things can just happen. So we're covered here, right? This will kind of, you can think of it as being done in our method if this case hits. If we get past this, then there's no problem, and we can return, remember we had to return an integer, larger modulo smaller, right? I didn't divide because we want the remainder, and that's what I was hoping you would remember, is that this percent sign operator is the modulo operator that gives you the remainder, not the quotient. So I think this will cover us. Go ahead and run a test. You can run the tests whenever you want to make sure you're on the right track. I got a lot of green there, which is my favorite color on Code Wars. And we are cleared for submission, which is great. Get our points. We can go over actually, I was going to say we could do the ternary operator, but it's a little weird here with the we got this bit where we have to find out the smaller and then possibly throw an exception, and it's going to get longer than I wanted it to be. So if you want to go ahead and make one of those long ones, you can go for it. I don't think what I have here is that bad, so I'll probably just submit what I have. Okay. And then as usual, we can check other submissions and get some more ideas for the future. So, oh, this one was nice. I'd forgotten about this. So they use this math class. You can look that up, the C# math class. And it's got a max method. Takes two numbers, so that will automatically give you the bigger one. Use the minimum to get the smaller one, and they're already ordered for you. So I like that better than what I did. What do we have here? Math min. Yeah, you get your divide by zero exception check first. So I'm actually kind of worried about this one now. Where did they cover the divide by zero? So yeah, I like how they did that. But essentially the same thing, just with the divide by zero check. And then here you go again with the ternary operator. See, it's simple if you don't, it's simpler if you don't check for the divide by zero. So what this is telling me, I'm worried that the tests that CodeWars ran didn't put zero in there. Anyway. And the same kind, well, they modified into an integer array, that, and then they used links. So this is overly complicated. They completely changed the signature to an array, and then they pass in the two numbers in a collection of integers, and then they're sort of searching through the collection. It's not bad in this case because there's only two entries to get the max and the min. Okay, I think that's overkill though. And they got some divide by zero checks here. Notice what we didn't do. You can add string messages into your exceptions. That's useful. You'd want to write some meaningful message in there that can help you. That's a nice touch. I like that. But I don't like the if some condition return and then do the else. Like, you don't even need the else at that point. We talked about that in a previous video. And then look at this. We're internet famous now. Here's Syntactic Sugar Daddy coming in at the 10th slot or whatever. And yeah, these are starting to get repetitive now. So, but you can see the utility of looking through these. Gives you good ideas. Anyway, you know where to find me with questions. Otherwise, I'll see you in the next one. Thanks for watching.